Hi friends, welcome to another episode of Decluttered. In today's episode, let's look at a very interesting probability question. Now this question has got something to do with continuous distribution. Take a couple of minutes, try solving the question and then come back to me for the solution. Let me give you a brief overview of the question. Two people decide to meet between 8 a.m. and 9 a.m. So they have a certain window of time that is available to them. Both of them independently decide at what time they are going to come to the designated spot of meeting. However, both of them say that we will not wait for each other for more than 10 minutes. And the events are independent in a way that if I was one of the persons and I reached the venue before the other person, I am not going to influence his or her arrival time by constantly calling the person and asking where he or she is. So both the people's arrival is independent of each other. The question is, what is the probability under these circumstances both the people will meet? Try solving this and then come back to me for the solution. Alright, what I can do is, I can draw a graph denoting person A on the x-axis and person B on the y-axis. I am going to draw a square of 60 by 60 where 60 minutes and 60 minutes is the time window for B. Now what this means is, if there was a point here, let us say this was 7 minutes and this was 20 minutes, what this means is that person A has come 7 minutes after 8 and person B has come 20 minutes after 8. In this case, both the people will not meet because A would have said, I have waited for 10 minutes. So after 17 minutes, A would leave the place. This is how every point inside this square can be defined, and it will define a unique placement of the time of arrival of person A and person B. The total possible options in this way is the area of this square, which is 60 into 60, which is my total cases. Now, let us look at what is the case in which both the people will actually meet. This diagonal of the square is the every point where both of them arrive at the same time. So anywhere they lie on this, both of them will meet. Now, let me take a point that is 10 minutes above 0, 0 and 10 minutes below 0, 0, which means if person A and person B arrive at a point that is anywhere inside this shaded region, they would have arrived at a gap of at best 10 minutes from each other. So if the both people arrive anywhere within the shaded region, they will meet. So our favorable cases is actually the area of this shaded region. How we can simply do it is, the length of this triangle is going to be 50 and the width of this triangle is also going to be 50. The area of this triangle is half into 50 into 50, and since I have two such triangles which should not be included, the total area of the cross is 50 into 50. So my area where they are going to meet is 3600 minus 2500 is my favorable cases, divided by 3600 is the answer, which is 1 minus 25 by 36, which is going to be 11 by 36. And that is the probability where both person A and person B under this situation will meet. It is important that their arrival times are independent and not influenced by each other. Otherwise, there will be a function which comes in after a person has come, how persistent he is to call the other person, and it makes this question a little messy. I hope you liked this video. If you did, do like, share, and subscribe to our channel. Thank you.